Okay, welcome. So this is for Module 2. So we're going to start the inferential statistics in earnest now. So last week we covered the basics of statistics, and hopefully you learned some terminology from last week, and you're comfortable using the spreadsheet to calculate the numbers. So we're going to be switching gears and then start inferential statistics. So when we say inferential statistics, basically what it means is what it sounds like, looking at the data and we make some inferences. And so how do we do that? So that's what we're going to get started here. So a few things. I still do recommend you read the lecture notes here. These are the things we're going to be covering today. But just kind of like in a summary way, just kind of understand the background information on how to do things. We'll do the calculations in Excel, and I have a separate file that will talk about the concepts in a little bit more detail, or maybe in a different way so it's easier to understand. So the first things we're going to be doing is that we're going to be looking at the estimates and sample sizes. And what does that mean is that we're going to be looking at estimation. So we're going to look at the numbers. And first thing we're going to do is calculate some estimates. Last week we learned about different parameters. So the proportion, the mean, the standard deviation, and then the variance. So we're going to be calculating the estimates for the proportion, the mean, and the standard deviation. And we're going to be looking at what we call the confidence interval, and I'll explain what that means, but that's what we're going to be doing today. And next week, what we're going to do is we're going to expand upon that and go into what we call the hypothesis testing. So that's the meat of inferential statistics. But before we get to that, we have to have some basic understanding of how to calculate the estimates. So that's what we're going to be doing. The steps, so the calculations at first look a little bit complicated, and there are a lot of steps, and I understand there are a lot of steps, and if you haven't seen these things, it's a little bit mind-boggling, but I'm hoping to make things pretty simple and straightforward. Once you get over the hump, the steps are pretty straightforward and pretty logical. There are a lot of things going behind. So we're going to be using Excel spreadsheets to calculate things. And there are a lot of things going behind the scenes in order to calculate those numbers. But I hope you don't get hung up on the details, like the theories behind, but get comfortable with the process, like step-by-step, how to do these things, and you get comfortable following the steps and logic. So the steps we're going to be taking are listed here. The ultimate goal is we want to figure out the confidence interval, and that involves things like finding the critical values and the margin of error, and I'll show you how to do that. We begin by calculating the point estimate. The second part is that in order to have a good sample, so that the sample size that's big enough for us to make a good estimate, there's a minimum number you need to have as far as the sample size goes. So I'll show you how to calculate that, determining the sample size. If you're doing this in the real world, what is the minimum number of people, for example, you need to survey in order to make your calculations good? So we'll start with the proportion, and the next parameter we're going to be looking at is called the population mean. So we'll move on to that. The steps are the same, and lastly, we're going to be looking at the estimation for standard deviation. So we'll do proportion, mean, and then the standard deviation in that order. All right, so let's look at the spreadsheet, which is available from my website. I meant to bring it up here, so it's in the announcements area, but here's the link. I'm just reviewing it just for the people who haven't gotten this yet. So you go here, this link, and it will take you to my classroom. So then you just go to 3215, that's your course numbers, and then in week 2, it's right here. And here's a spreadsheet, and here's a PDF. So I'm going to look at the PDF first, so just so that you see where they are. So here's the PowerPoint slides that we created for you to kind of go over the details on how to do things. So I highly recommend you go through this so you understand the concepts behind what we're going to be doing today. I'm going to be focused on doing the actual calculations because, I mean, I could read this to you, but it's going to be not very interesting. So here's a summary of what we're going to be doing. So I recommend you read the PDF first. There are 2 of them. And then come back and maybe watch the session to follow along the calculations. Okay. So here's a spreadsheet. If you double-click on it, it'll open in the browser, but I recommend you download it by going to this down arrow and then download it. I'm going to go back and go to my actual spreadsheet, which one is it? Oh, this one. Okay. So here's a basic summary of what we're going to be doing here. So as I mentioned, our end goal is to find the confidence interval. That involves the margin of error and then the critical values and the point estimates. I'm going to go in that order here. So here's a point estimate. Okay. So point estimate, before I go to that, statistics, as you learn, has a lot of terminology, math words like jargon. And so I'm going to try to simplify it for you what it means. So when you hear point estimate, it just means that's our best guess. So what's this point estimate for P is point estimate for proportion. So what is the best guess we can get for proportion? The letter we're going to be using is P for proportion. And then the point estimate for that is called a P hat, P with a little hat. So this is called a P hat. So that if you're asked to figure out the point estimate for proportion, what you're looking for is the P hat. And then the formula for P hat is X over N. It's basically the proportion. So there are 2 ways to figure out P hat. One is, let's read the problem. A recent survey of 1,400 airline passengers suggests that 38% of airline passengers prefer aisle seats. So in this case, this 38% is the point estimate. Sometimes it's that easy, just given to you. So the P hat for number 1 is going to be 0.38. That's your point estimate. Most likely you have to calculate what that is. So here's a second example. A Consumer Reports Research Center survey of 427 women showed 124 of them purchased books online. Find the best point estimate for the population proportion of women who purchase books online. So the formula for that is X over N. So the question is which one is X and which one is N. N is the total number of people surveyed or looked at. So in this case, it's going to be 427. Out of these women, how many prefer to purchase books online? 124. So it's going to be 124 divided by 427. And if you use my spreadsheet, that's what this cell does. It does 124 divided by 427. And as you notice, I put little commentaries here and there to make sure you don't get the wrong numbers. So for example, if this number, P hat, is bigger than 1, you did it wrong because P hat is never more than 100%, so which means more than 1. So if your P hat is more than 1, you did something wrong. Most likely you flipped the numbers. Okay. So that's how you calculate the point estimate for proportion. As a side note, people ask me, okay, on the final exam, how do I know that I'm doing a proportion problem? Like I mentioned that you're going to be doing the proportion, the mean problem, the standard deviation problem. So students ask me, so how do I know I'm looking at the proportion problem? Well, it's going to be fairly easy because it's going to be most likely be very explicit, like this problem, proportion. So as I go through these examples, you see the problems are pretty explicit in as to what you need to find. So in this case, it's a proportion problem, so that's why I know to come to this spreadsheet, for example, this tab to figure out the point estimate. So that's how I know. So I recommend you read the problem before you think, okay, what am I being asked to do? Well, point estimate, proportion. Okay, got it. Do this part right here. So that's how you figure out the point estimate for proportion. So the point estimate for the mean is called X bar. So X bar, as if you remember from last week, it means the sample average, sample mean, and that is represented by this X bar character. So if you see X bar, you know that's the point estimate for the mean. Okay. The formula for that is this. It's a summation of all x's divided by n. I'm just showing this for reference only, so you don't have to know what it is. But X bar means average. So let's figure out the average. All right. So then a random sample of college students were surveyed to find the numbers of years it took them to earn bachelor's degrees. Find the point estimate of the mean time required for all students to earn bachelor's degrees. So let's say you're given this information here. These are the years the students took to graduate or to earn bachelor's degrees. Find the point estimate. Just basically find the average. Use the average function for here. Okay, so if you're to find the point estimate for the mean or the proportion, this is the tab to look at. All right, so I'm going to skip the critical values tab for the moment and go to this tab right here to explain what I'm going to be doing. Okay. So this tab is about the margin of error and the confidence interval. You probably have seen this, you just haven't realized what margin of error is and confidence interval. So I'm from the Chicago area, so if the local paper is called the Chicago Tribune, and the Tribune does a lot of surveys in its reporting. So here's one example from, or two examples from the paper. Richard Daley was the previous mayor, the Chicago mayor, and Tribune did a survey asking if the new guy, Rahm Emanuel, is he a better mayor or not? And here's the result. Okay, so the proportion we're going to be focusing on is this blue part, for example. So better off is 17%. If you look at the small print, you see that it surveyed 800 registered voters, and then the margin of error is 3.5 percentage points. So that's plus minus 3.5 percentage points. That's what that means. So what does that mean is that this range could be anywhere between 17 minus 3.5% to 17 plus 3.5%. So for example, 17.5 minus 3.5 or 17 plus 3.5. So this better off proportion could be anywhere between 14% to 20.5%. I calculated that by adding 17 plus 3.5 or subtracting 3.5 from 17. So 17 minus 3.5. And we get the margin of this interval. And this interval is called the confidence interval, basically. Okay. So 17%, that's the point estimate. Margin of error is the 3.5%. And then confidence interval is this thing right here. You see the similar thing over here where another survey said, okay, do you think the new mayor is honest and trustworthy? So 59% said no. We surveyed, the Tribune surveyed 985 people, got the margin of error 3.2% with the confidence level of 95%. So I'm going to be talking about all these things, but this is confidence interval in real life. So why do we have confidence interval? Well, because this number 17, for example, or 59%, these numbers are not static. So it's because, for example, the surveys of people people's opinions change constantly. If I did this survey on Monday and I got the 17%, I do the same survey with a different group of sample, I might get a number that's close to 17, but I probably will not get the exact 17% because people's opinions change constantly. But the number will be somewhere close to 17. If I did this over, say, 100 times, the number will be close to somewhere 17, but not exactly at 17 all the time. So what's that range going to be? That's what this confidence interval tells you. The number 7, this better off proportion will be most likely in between these two numbers over time if I repeat this survey over and over. So that's why we need to calculate the confidence interval, because this number is not static, and so we want to know the interval instead where this better off number is. Same thing over here. This 59% number is not static, so but we want to know the good range where it's most likely what this proportion is going to be. That's what the margin of error tells you. The confidence level tells you that I'm 95% confident that the real number, whether it's 59% or something else, will be in the range of 59% plus minus 3.2%. So in order to have a good survey, you need 3 things typically: number of surveyed, margin of error, and then confidence level. You don't see confidence level because a lot of papers do this wrong. This number is critical in showing what these numbers are, but if you read the papers, they don't. Most of the time, they don't show it. So this is one of the rare times that the Tribune pointed out the confidence level. Okay. Anyway, so how do we calculate these things? That's what we're going to be doing right now. So here's an example. I'm going to start with the proportion margin of error first. Going back to the earlier example, a recent survey of 1,400 airline passengers suggests that 38% of the air passengers prefer aisle seats. Find a 95% confidence interval estimate of the proportion, population proportion P. All right, so here's the, for one thing, 2 things. How do I know I'm doing the confidence interval problem? Because it says so in the confidence interval. It says so in the problem. The other thing to keep in mind is that this 95%, this is the confidence level, and that's going to be typically given to you. If it's not, you can assume a 95%. That's the most common. So if the confidence level is not given to you, you can assume 95%. But in this case, it says 95%, so that's what we're going to be using. All right, so to calculate the confidence interval, I mentioned that you need a margin of error. Margin of error, the shorthand is E, capital E. So if you see capital E, that means you're asked to calculate the margin of error. So margin of error is E. The formula for margin of error for proportion is this formula right here. Okay. You see there's a Z, P hat, Q hat, and an N. So you need 4 things in order to calculate the margin of error. That's what these inputs come from, is because of the formula. This Z is called the critical value, so that's why I have a separate tab to calculate the critical value, but I'll get to that in a minute. You know how to calculate the P hat, Q hat, and then N. So P hat, as I mentioned, is going to be 38%. If you know P hat, you know the Q hat. It's 1 minus P hat. What's the confidence level? That's what the CL stands for. So that's 95%. So I enter this, and then how many people? 1,400 passengers. So that's what the N is. So now I need to figure out this Z value, which I know to be 1.96. But how do you figure this out? That's when this tab comes into play, the critical values. Okay. So here's a tab that tells you how to calculate the critical values, and it's broken up to a couple different things. So you see that title that says for this section is for confidence interval or two-tailed test. You don't know what this two-tailed test means right just yet, but if you're asked to figure out the critical value under the confidence interval problem or two-tailed test problem, here's the section you come to. Okay. And this is this section for critical value Z or T. Okay. Later on, we're going to be looking at right tail, left tail test. If the problem is that, you come to this section. If the critical value is what we call the chi-square, which I'll cover in a little bit, then you come to this section. Okay. Same thing for right tail, left tail. So for the proportion, I'm telling you that the critical value is Z. So you look for Z, which is this section right here. I have already calculated the most common critical values for you, so 95%, 90%, or 99%. So this, if you change these numbers will update themselves. So for 0.95, critical value is 1.96. If the critical or confidence level is 90%, it's going to be 1.645. If it's 99%, it's going to be 2.58. By the way, if you see errors here, that means you have an older version of Excel, so you have to call up personal support to get your copy of Excel updated. So this is a live spreadsheet. So let's say I'm asked to find the critical value for confidence level that's not listed here. So for example, like 80%. You just overwrite this cell right here. And then this critical value automatically change. So you can just use this, whatever these cells in order to figure out the critical value for any confidence level given to you. So 91, if it's 91%, just type it in and this will change. So it's going to be 1.70. Okay, so just FYI, you can use this to calculate any critical value. And by the way, the assignments or maybe the lecture notes might tell you to refer to the tables, critical value tables, to figure out the critical values. You can, but you don't have to, because this spreadsheet, this part will calculate any critical value for any confidence level. So you can use a table, but you don't have to because it's already right here for you. So now you know how I got the 1.96 here, because confidence level is 0.95, 1.96. And this section will automatically calculate the margin of error for you. So this cell reproduces this formula here. So I get the margin of error 2.54%. So that's the first part of it. The second part is you need to figure out the confidence interval. So the confidence interval formula looks like this. The p hat minus e for the lower end, so that's this 14%. And p hat plus e, so that means p hat plus the margin of error. That's the upper limit. So I'm going to calculate these equivalent over here. So that's what these cells do. So 0.35, that means 0.38 minus 0.025 to get this. And this number is 0.38 plus 0.025 to get this number. So that's the interval. Okay? So that's how you do the calculations. Do you have any questions, Sarah? I'm just kind of rambling here, but I'm sure you'll type it in if you have any questions. Okay. So that's how you do the proportion. Pretty easy. So let's do the same for margin of error and confidence interval for the mean. Okay, the same problem from before, but I'm going to figure out the confidence interval, 95% confidence interval for the mean time to get a bachelor's degree. All right, so this was the information given to me. So I calculate the mean, and I calculate the standard deviation here. Okay, so I calculate the mean because that's the best point estimate. And I need to figure out the standard deviation because if I refer to the margin of error formula for the mean, here's the formula. It has three parts, the t value and s and then n. I know n, that's going to be number of people surveyed, so that's going to be, if you count the number of data points here, there are 31 of them, so that's how I know it's 31. I need to figure out the s, so here's s, standard deviation s from last week. I know n, so now I need to figure out the t. So let's go back to this tab here. Here's the section for t. T is called the student t, and we use t in place of normal distribution. So the z is associated with the normal distribution, and that's what we want to do ideally. But if you read last week's lecture notes, you realize that the normal distribution has strict requirements where you have to know the mean and then the sigma value, standard deviation value. If you don't have sigma, you're forced to use the next best alternate, which is the t distribution. So if you don't have sigma given to you, where you have to calculate the s yourself, then your only option, at least in this class, is to use t distribution, which is called the t distribution. So that's what this section is. One key difference is that the t distribution depends on what we call the degrees of freedom, which is basically one less than the sample size. So this is what it is. So I know 31, so 31 here. And this section will automatically calculate it for you. So if you do 31, assuming 31, confidence level 95%, then critical value is going to be 2.04 roughly. Okay. And that's what it shows here. If you enter this number correctly, this section will automatically calculate the t value and margin of error. So this cell is replicating this. Okay. So the margin of error, confidence interval is going to be this formula again. X bar, point estimate minus margin of error is the lower end. And the upper limit is X bar, which is the point estimate plus the margin of error. So these two cells are doing what this is. So the interval is going to be 5 years to about 7.3 years. Okay. Now, oops, there's more. Okay. We're going to do something else, but let's move on to the next one. So, before I do that, let me go to the sample size for proportion and then the mean. Okay. You saw that, for the example, for this survey, 985 registered voters were surveyed. So this one here, it was 800. So there's a minimum number you need in order to make the survey valid, basically. If you only survey 10 people, your survey is not going to be very good. But you don't want to survey more than required number, because more people you survey, more money, more time, and then after a certain number, there's diminishing return. So you want to survey minimum number you need in order to make the survey good. So what's that number? That's the sample size. Okay. So here's an example. Here's sample size you need for the proportion, and then the formula is this when the p-hat is known. If you don't know p-hat, you use this formula right here. So let's apply this to figure out n. You've been given the task of estimating the percentage of Southwest flights that arrive on time, which is no later than 15 minutes after the scheduled arrival time. How many flights must you survey to be 95 or 90% confident that your estimate is within 3 percentage points of the true value? Assume that for a recent year, 84% of Southwest flights were on time. So how many flights do you have to look at in order to get the estimate within 3 percentage points? Okay. So in order to calculate n, you need 4 things: z, p hat, q hat, and then e, the margin of error. So where are those? Well, p hat is, in this case, is 0.84 because that's the 84% that's arrived on time. That makes q 0.16, 1 minus 0.84. What's the confidence level? It was given to us, 90%, so I'm going to put that in here, which makes z value 1.645. What's the margin of error? Well, typically you have to calculate it, but for this problem it was given to you. That was 3 percentage points. If I convert that to a decimal, 0.03. So if you enter these numbers, it gives you this. Okay. Typically you want to round up just to be on the safe side, but in this case it's 404.0, so you can chop it off and just use 404. So in this case, you look at least 404 flights in order to be within 3 percentage points. Okay. If you don't know p hat, if the p hat's not given to you, just change this number, 0.84, to be 0.5, and then everything else will follow. Okay. That's if you don't know p hat. I'll do the same for the mean, which is, the formula is this. So I need to know z, sigma, and then e in order to calculate n. So suppose the confidence level is 95%. We want to calculate the necessary sample size for sigma of 15. Assume that the e is 5, calculate n. Well, this is just basically plug and chug. What's z? 1.96. We know that from the previous calculation. What's standard deviation? That's given to you as 15. E is given to be 5, so if you punch those numbers in, this cell does what this is. Okay. As I mentioned, you want to round it up, so in this case, I'm going to round up to the next whole number, which is 35. So at least 35 people, or whatever this is. So at least a sample size of 35 is needed here. Pretty easy. Okay. So now you know how to do confidence interval and the sample size for the proportion and then the mean. So before I get to the standard deviation, one thing I want to mention is you can use my spreadsheet to do quizzes and assignments. So how do you use this? How do you use my spreadsheet for your quiz or for your assignment? Let's say this, you do an assignment here. Oops, too big. Problem 1, for example. Okay, let's say the problem is about the proportion. And I want to use the spreadsheet here. Oops, not that one. I want to repeat this. The way to do that is just copy and paste. So I'm going to copy here, highlight everything, go to copy, click, and go to your assignment spreadsheet, and then just paste. Boom. Okay. Everything is covered, so just delete anything that's not necessary. And then whatever the problem is, say proportion is 0.65 for whatever, confidence level is 99%, n is 900 or whatever. I'm just making those up. But whatever the numbers are, you can just overwrite them. And then the spreadsheet will automatically update to give you the correct numbers. Okay. The only thing it does not update is what's in the text box. So you see that this didn't update, but then you can just overwrite it. In this case, say 4.10 for whatever it is. Okay. So you can just copy and paste from my spreadsheet into your assignment home or assignment file. So you don't have to retype anything. Like you don't have to retype all this stuff. Just copy and paste. Okay. So now let's move on to the point estimate for the confidence interval and the margin of error for the this thing, chi-squared. So we did all this thing just now. Okay. What's this? Okay. So I'm going to go to the second half of this class, which is in the second part PDF. Okay. So the associated distribution for standard deviation and then the variance, it's called the chi-square. And the letter for that looks like this. It looks like an X, but it's chi, Greek letter. And it's pronounced chi-squared. So that's what I'm going to be using for the variance and then the standard deviation. Okay. We won't be doing the point estimate. We're just going to go straight to confidence interval for chi-squared. So here's what the sample example looks like. A group of 22 subjects took an IQ test during the part of the study. The subject had a standard deviation IQ score of 14.3. So, boom, there you go. I know I'm going to be doing standard deviation. If it's standard deviation, most likely I'm going to be using chi-squared. Construct a 95% confidence interval estimate for sigma. This is not a O. O with the little tail, that looks sigma. That's the shorthand for standard deviation for the population from which the sample was obtained. We'll assume that the sample is simple random sample and normality assumptions shown by the histogram to the right. Okay, so that's most likely going to be the case. So it looks like a normal distribution, so that's good. So I need to figure out the confidence interval for the population standard deviation. And the formula for that looks like this. Okay. The N, S, and chi-squared the right-hand side, and chi-squared left-hand side. So I need to figure out the chi-squared to the right value and chi-squared to the left value. And why is that? Well, I'll have you read it. But the main reason is because chi-square distribution is not symmetrical. So there's going to be a different value for chi-square right value and chi-square left value. Okay. So that's why I need to figure out the left side and then the right-hand side. So for more detail, you can read the PDF here. Okay. Anyway, for the calculation purposes, you need to figure out the right-hand side and the left-hand side. The N and the S are common. So I need to figure out N, S, and chi-square, and that's what we're doing over here in this section right here. So what's S? It was given to us, 14.3. What's N? We looked at 22 subjects. That makes the degree of freedom 21 and then minus 1. What's the confidence level? 95%. There you go. If you put in these numbers, this spreadsheet will calculate the chi-square left side, chi-square right side, and then as well as S squared. And then it will also calculate the confidence interval here and then here. So this over here is this. This over here is over here. Alrighty. We're taking the square root because this is the formula for the variance confidence interval. And if you remember, the relationship between the variance and the standard deviation is that the standard deviation is just the square root of the variance. So if you have the formula for the variance confidence interval, you see that by sigma squared. You just got to take the square root of all of these. That's what we're doing here. So if you're given the variance interval already, say 121 to 417.6, all you got to do is take the square root over each number. If it's not given to you, you have to calculate everything, then you just follow along with what we just did here to figure out the interval. Okay, so using my spreadsheet, I see that the confidence interval for the sigma is 11.0 to 20.4. Okay, so that's the confidence interval. Now, only one thing left is the sample size for the variance or standard deviation, which is in this tab. Good and bad news is that if you try to do it by hand, figure out the sample size for the chi-squared by hand, it's too much work. So we're not going to do that, and I don't think you'll complain. So instead, what we're going to do is use the table that's in the book, which I reproduced it here, in order to calculate the sample size. So how do we use a table? I'll show it to you through an example. We want to estimate the standard deviation sigma of all voltage levels in a home. We want it to be 95% confident that our estimate is within 20% of the true value of sigma. How large of a sample should it be? Well, a couple things. We know the confidence level is going to be 95%, and we're looking at the standard deviation. So, if you could look at the table, it has two main columns, standard deviation column, and then the variance column. Okay, so 1, 2. Oops. And so we're going to be looking at this side right here. And we're going to be looking at 95% confidence versus 99%, so we're going to be up here. And lastly, we want to be within 20%, so look at the 20%, which is right here, so it's going to be 48 in this case. It's as simple as that, 48. So that's how you look at the table. Okay, so this week you have discussion. So now you know how to do the discussion. You have phase 2 assignment, which I'm going to show it to you in a bit. Go over a little bit. Where we go? So here's phase 2 of the course project. So now you know how to do all these things. Okay. Assuming that the population standard deviation is unknown, so now you know which one to use, Z or T. Write the report on this, and you compare the difference between 95% confidence interval and a 99% confidence interval. If you do both 95% confidence interval and the 99% confidence interval, you will notice a difference. And then your job to figure out why is there a difference. That part I haven't explained to you because that's something you have to research. So you can either look in the book or maybe look up the library or maybe look it up on the internet, but there's going to be a difference, and then there's a reason why they're different. So that's why you need to find for this part of the assignment. Okay, so hopefully you have noticed that by now that the spreadsheet I give you can do both the quiz and the assignment as well as the project. So use my spreadsheet to answer the questions for your course project. Okay? So that's the course project. And here is the assignment, homework. Okay, you can download it here. And for just this week, I'm going to give you the answers. Okay, because I need you to be able to reproduce it. So, okay, so the assignment, it's in the Word document. It's gonna look like this. Where'd it go? It's gonna look like this. You can do your assignment in Microsoft Word. You have to do your calculations in Excel and then copy and paste it here. You can do that if you want to, but you don't have to. I recommend you just do your assignment in in Excel. Just leave it at that. So you can turn in either the Word document, Excel spreadsheet, or both. But my recommendation is to just turn in the spreadsheet and to look like this, for example. Okay. So in your assignment, it should look like these. Oh, you don't have to retype the problem, but just have these parts here. It's just there for my reference, but these are the things that should be in your spreadsheet. So just save it as a spreadsheet assignment. Just turn this in. Okay. So just for the first week, or for this week, just so that you guys can get going, I'm going to give you the answers. Your job is to reproduce these in Excel. Like, how do I get this number? I'm not going to click on it, but I need you to figure out how to get this. So here are the answers. Here are the answers. I'm just going to scroll. You can pause it and look at it later. So be sure you're able to reproduce these numbers. And if you cannot, let me know and I'll help you out. By reproduce, what I mean is I reproduce these numbers using the spreadsheet. Okay. So now you know how to do the assignment. And lastly, the quiz, which I'm not going to open it up, but if you did the assignment, the spreadsheet, like if you understand the spreadsheet, you will be able to do the quiz after you've done all that stuff. So the spreadsheet will help you with the quiz as well. All right, so that's all I have for today. There, as a representative of the class, do you have any questions? Okay. Then, as usual, let me know if you have any questions. Any updates going to be up in the announcements or course wall here, so just follow along. If you're late with the assignment, it's not a big deal. Just turn it in. I'm just basically giving everybody automatic 1-week extension for all the assignments except the very last week. So if you're a little bit late, if you're panicked a little bit, don't worry. You still have time. After 1 week, assignments go to 0, so that's just a nudge from your end. But other than that, if you're late with assignments, not a big deal. I still urge you to do the discussion post on time, but other than that, I'm okay with late assignments. So I'm going to stop the recording here.